Okay, Bismillahirrahmanirrahim. So today after motivating you, right, and you know what we are going to study, so let's start the course with simple concept like number system, right? So today we'll talk about the number system. Okay, let's quickly review last time what we did. Basically we said that because we are trying to understand the building blocks of computer, right? And computer basically manipulates discrete information. That's basically ones and zeros or two logic levels, right? Two logic levels. And in it here, our logic levels are 5 volts and 0 volts, right? Maybe some other logic, it has different voltages, but it has discrete information, right? Okay, and he said that is restricted to finite. He said anything which is countable, finite, right, is discrete. For example, if I say 10 digits, 0 to 9, they are 10 digits, so they are discrete values, right? And then we have 52 playing cards. That's again discrete. We can count 52 cards, and we can, more than maybe when we are making a game, 64 squares on the chess, right, and so on. And we last time gave a lot of examples of position system where we said 10 position switch is also a discrete information, right? Rainbow colors are discrete information, traffic lights are discrete information, right? So everything is discrete in nature. So we are, with the help of this, basically we are dealing with this. And then now the discrete information has to be represented in the form of signals, right? What type of signals? Maybe a voltage, maybe a current, right? And in this case, our logic 1 is 5 volts. We are representing it with the voltage, right? And 0 volts are our logic, another logic. And there could be current also. The current is flowing or is current not flowing, right? Or current is of this value, then it is logic 1. The current is not there, 0 current, then we say so logic 0. So it depends on what type of signals we use. And for simplicity, we use digital signals or binary signals, right? More specifically, binary signal, right? So everybody understand now? And we said, what was the reason for binary? Because we have a device which has two states only. A transistor can switch, and working as a switch, it can have two states only. Either it's cut off or it's in saturation, right? There are only two states possible. If the transistor had 3 states, then we could utilize the 3 discrete values, right? It has only 2 states, switching mode, it has only 2 states, that's why we are using those 2 states, and our whole thing is based on binary. Right? And what is binary? Only 2 states. And one higher logic, we say 5 volts, or higher voltage, we say it's a logic 1. And if the lower voltage, we are saying logic 0. Right? So it's just a game of ones and zeros. Right? When you are, let's say, listening to a song in the computer, right? You're downloading a song, so a lot of ones and zeros are downloaded, and then those ones and zeros are crunched by the computer, and then it's converted into analog, and you listen to a song to the speaker. Right? So inside everything is ones and zeros crunching, right? Nothing else. Because the machine understands only ones and zeros. So that's why we have to just start from there. Okay, here is a very important point that let's say with the binary values, let's say binary values, how many quantities we can represent? Right? For example, I want to represent 2 quantities. 2 quantities means two distinct values. Right? For example, I say the torch is on or torch is off. So how many bits I need in binary? 2 bits. So I need single bit because I know in binary it can be either 0 or 1. So for representing 2 quantities, I need a single bit, right? So because I said in binary, right? In binary, I have two values only, 0 and 1. And 1 was 5 volts, right? 0 was 0 volts. So I'm representing a signal, right, in terms of logic, right? And then I'm not mentioning the voltage, I'm only mentioning the logic, right? Logic 1 and logic 0. And this is my positive logic. And I said earlier, logic can be different. 5 volts I can say is a logic 0, and 0 volt I can say is a logic 1. And that's negative logic, right? So once I assign these values, for example, I want to represent certain quantities. So with the help of a single digit, right, because my digits are 0 and 1, right? So with the help of this, I can represent two quantities. For example, I want to show, let's say, the bulb is on or off, right? So bulb on oblique off. So I can represent this with 0 and 1, only single bit. So two discrete values I can represent with single bit. Right? Okay. Let's say if I want to present three colors, let's say I want to represent the traffic light colors, and let's say red, yellow, and green, right? So how many bits I need to represent these three distinct quantities? At least I need 2 bits. Why? Because my one single bit can represent two quantities, and if I increase the number of bits, then I can represent more. For example, if my single bit is, so I can have 2 bits, right? And let's call them A, B, right? Let's call them A, B. So either, because single bit have a value of either 0 or 1, right? So what are the possible values? Both are 0, right? Or this is 0, this is 1, this is 1. Another possibility is this is 1, this is 0, right? And what is the last possibility? 1, 1. So it means 2 bits can represent how many distinct quantities? 4 quantities. So 3 comes within 4, so we need at least 2 bits. So we need 2 bits. And that's very, very basic principle. And this principle will go on even we study computer architecture, we study memory, we study everything based on the digital. This is very, very important concept. Right? And people normally forget that how many bits can represent how many quantities. Right? For example, I have 7 colors, rainbow colors, 7 rainbow colors. Rainbow colors, right? So how many bits I need for 7? I need 3 bits at least, right? Because, and 3 bits can represent how many quantities? Can represent 8. So can I generalize this? Let's say I have n bits. If I have n bits, okay, single digits is called bit, right? So if I have n bits, so how many quantities? How many quantities? जी कितनी जी? 2 raised power n, right? And the numbers will be basically 0 to 2 raised to power n minus 1. For example, here we said, and later on we'll see this is equivalent to 0, 1, 2, and 3. Right? So we are representing 4 quantities from 0 to 3. We can give out very, very fundamental thing, right? और यही concept आगे memory addressing में भी use होगा. Let's say we have 10 locations, we have 10 garages. Let's suppose we have 10 garages here. We want to, let's say, build a system where we have 1, 2, 3, 4, 5, 7, 8, 9, and 10. So we have 10 garages, right? So and we want to park the cars, right? If any car comes and maybe we have a sensor, when it goes there, we say that particular garage is occupied. Right? So in order to get the address, now I have 10 quantities, right? The can you tell me how many bits I need for giving the discrete locations? I need at least 4 bits. Right? Because, and 4 bits can represent how many quantities? 16. So that's a very, very fundamental principle, and you have to really understand that. Right? Later on, we'll be representing the quantities or discrete information into binary, so this principle you will not forget. Right? For example, so what addresses I can, if let's say I want to give the addresses not in numbers, for example, the number could be, let's say, 0, 1, decimal numbers, I'm talking about 4, 5, 6, 7, 8, and 9, right? 0 to 9, 10 garages, right? And now I want to code this 10 garages into binary. And we learn how we write binary, right? But I need at least 4 bits to represent the addressing. For example, here, if let's say if I start from 0, 0, so this will be my address. This will be my 0 address, right? This will be my 1 address, and so on, right? So 1, 1, and so on. And this will be 9, 1, 0, 0, 1, right? So I need at least 4 bits to represent 16 quantities, and 10 lies in that 16 number, right? So I need that. And let's say if my garages were 8, so how many bits I need then? I need 3 bits. Because I can represent 8 quantities with 3 bits. So that's very, very important principle. Just keep this principle in your mind, and later on when we do everything in binary and talk about the real world problems, this principle should not be forgotten. Okay. So let's talk about the number system, right? So, in the number system you are familiar is decimal. Most of you have been doing mathematics, the decimal. Before that, what kind of number system was there? I mean, if you talk of very early stages, I mean, people were counting on figures. 5 उंगलियां थी, वो 5 तक ही काउंटिंग आ रही थी. Okay? They used to count till 5 only. तो अगर उन्होंने 5 के बाद 6 गिनना होता तो फिर कैसे गिनते थे? 5 plus 1. Right? So they were not exceeding 5 and then 6. Right? They were saying 5 plus 1. Then they used to, maybe count the goats, right? So they used to count it on fingers because that was the most. और जो पढ़े लिखे लोग थे वो भी इंग्लियों में ढूंढते. So at that time the number system was base 5, right? But later on, as the revolution came, the Arabs basically gave the decimal number system, and that's the most advanced number system where a single digit is adding to, let's say, unit, 10,000, and all of that, right? And then maybe shifting by 1 decimal, you can change the number. And that was a big invention at that time, right? The decimal number system. And we are familiar from the very beginning. We are taught with the decimal number system. We haven't heard about any other number system. And today we'll talk about, in general, what is a number system, right? For example, if I write this thing in decimal, and everybody understand, this is 5,382. So why I am calling this as 300? Why I am calling this as 5,000? Is there any reason? Base is a place. Okay. So maybe it's a place. You say because the 8 is lying at this place, that's why it's 8. Right? If 8 would have been here, then it has 8, unit 8. So we have unit, 10, 100, and 1,000. Right? So if you look here, this number is basically 5,382. And if I break this, that's the weightage. Right? This 5 has a weightage of 1,000. That's why I'm writing this 5,000. 3 has a weightage of 100. 80 has a weightage of 10. Right? And the last one has a weightage. So if I write the same thing in the powers of 10, you can appreciate it better. Right? That it is in the power of 10. Everything is in the power of 10. And then we have some numbers that is multiplied by that weightage. Is understood? Right? So if I talk about any system, I have digits. I have digits like this, digits. Right? And then I have bases. and every base, the last digit is whatever is the base. In decimal number system, we know the base is 10. Right? Because the 10 multiples of 10. Right? So the first digit is 10 raised to the power 0, which is 1. That's why we say unity. Right? The second digit has a weightage of 10 raised to the power 1. That's why we say it's a 10th digit, 80. Right? And then 100 and 1000. Right? So if you look at some other system, let's say base 5 system, what do you think, what it will be? So if I write a base system, let's say in let's go quickly. If I write, let's say, 302 in base 5, so can you tell me what is this number? So we know that this digit is multiplied with the weightage, with what? Whatever is the base, 5 raised to the power 0. And then this has a weightage of 5 raised to the power 1. So it has a weightage of 1, it has a weightage of 5, this has a weightage of 25. It's a multiple of 5. So here the thing is multiple of 10. So now you can correlate any number system with decimal number system. Okay, good. So let's go further. And if I write this number, so what kind of digits you find? Only 2 digits, 0 and 1. So what do you think? What is this number? Is it binary? Right? And can you know what is this number? If I want to ask you, what is this number? So can you tell me this number? So how you will find? So first of all, you will find what is the base of this number system, and then the first digit is, let's say if the base is 2, you're saying it's a binary, so the base is 2. So the first digit will have a value of 2 raised to the power 0, then 2 raised to the power 1, 2 raised to the power 2. So it's multiple of 2. Right? So if I write the weightages above and then multiply these digits, and it's very easy. If I multiply with 1, I'm basically getting a weightage. Right? Because multiplying with 0, the weightage is gone. Right? So what basically, if I look here, right? So can I write the weightages here? So let me write the weightages. So 2 raised to the power 0 is 1, right? And then 2, then 4, 8, then 16, then 32, then 64, then 1024, then 2048, then 4096, okay, and then इसको 2 से मल्टीप्लाई करते हैं, so it's a multiple of 2, so you keep multiplying by 2, you'll get the other one. ठीक है, अगर नहीं भी पता तो इसको 2 से मल्टीप्लाई करते हैं, 6 2 से 12 हो जाएगा, ठीक है, 8190, right? So in this way, and then you can carry on, right? So, and what is 1024? 1K, right? Remember, 1K is 1024, not 1000. In binary, 1000 or 1K is 1024. Right? तो इसका मतलब है कि अब आपको सारे कंप्यूटर 1s and 0s में मैनिपुलेट कर रहा है, so we have to learn now table of 2 at least. ठीक है? 2 का मल्टीपल टेबल आपको ज़बानी याद हो जाना चाहिए, ताकि आपको कहीं भी मसला हो, you can always write down the weightages, multiply the weightages with those numbers, and you will get the number. Okay? So, but just carefully look here. I'm trying to see what is value of this number in decimal. मैं decimal में मतलब इसको लेके आना चाह रहा हूँ. So I'm trying, because I'm more familiar with decimal. So I'm always correlating any other system and trying to see in decimal. ठीक है? तो let's say if I write a smaller number.
सर राइट साइड पे डेसिमल की बात ही ऐसी है।
जी जी, वहां पे देखिए पावर माइनस में चले जाएंगे। यहाँ क्या हो जाएगा? 2 रेज़ पावर -1। 2 रेज़ पावर -1 कितना होता है जी? 0.5, राइट? और 2 रेज़ पावर -2 0.05, सॉरी 0.25 डिवाइड बाय 2 करते जाएं, ठीक है? और 2 रेज़ पावर -3 दैट इज 0.125, राइट? तो ये आगे डिवाइड होते जाएंगे, ठीक है? So you have understood the point here. Let's see what's the number. So base is 2, right? And my digits, what are the digits in the base 2? 0 and 1. Only two, because we know base. And okay, remember, if the base is 2, so my number may be starting from 0 and then 1, right? If my base is 10, so my numbers are starting from 0 and going to 9. If my base is 5, what are my numbers? 0 to 4. Right? So my digits are always less than my maximum digit. Right? One less than the maximum digit. So my digits are 0 and 1. Right? And this is the binary number system. And now I can find out the weightage. I just apply, I know this is base 2. Right? So I just know the weightage of this, and then I multiply the digit with the weightage and just sum them out, right? And you could see I just do that, okay? And that comes out to be 89.6.
सर इसकी बेस चेंज हो जाएगी।
जी,
इसकी बेस चेंज हो जाएगी।
बेस 10 होगी, डेसिमल में कर दिया। तो इसका मतलब ये हुआ कि any number system, if I write some other number system and I want to know what is the number in decimal, so what should I do? Write the weightages, multiply the digits with the weightages and just add them. Right? So this is just called power expansion. It's called power expansion. Okay? So let's say if I write this number, so can you tell me what is this number? Let's say 314. So what you expect? Is the power can be 4? No, it can't be 4 because if the base is 4, my digits, these digits value have to go from 0 to 3. So at least maybe it's digit 5 or maybe digit 6, right? Base 6. So can you tell me what is this in decimal? 84. So what is this? Unit 1. Then 6 raised to power 1 is 6. 6 raised to power 2 is what? 36. ठीक है? 180, right? So I multiply, right, 3 with 36, 1 digit by 6, right, and then 4 by 1. And this comes out to be 118. Okay. So I know that this 118, which is in decimal, we are familiar, is written in base 6 like this. Right? So we can have any number system. So now you have understood what is the basis of any number system. Right? We talk about, let's say, binary system, which is base 2. We talk about octal number system, that is base 8. Right? Talk about hexadecimal number system, that is base 16. So everything principle is same. ठीक है?
सर वो जो डेटा है 118
जी,
बेस 9 भी लिख सकते हैं।
नहीं बेस 9 कैसे लिख सकते हैं बेटा? अब उसको बेस 9 में हम कन्वर्ट कर सकते हैं, दैट इज डिफरेंट। बेस 10 में हम देखते हैं जब पावर एक्सपेंशन करेंगे तो हमेशा डेसिमल नंबर सिस्टम, विच इज बेस 10। ये अभी देखते हैं एक हाउ वी कन्वर्ट फ्रॉम वन बेस टू अनदर, राइट? ओके, सो नाउ एवरीबडी अंडरस्टैंड दैट R, अब इसको जनरलाइज करने लगे। R is the radix of the base of the number system. R क्या चीज है? बेस है या रेडिक्स भी इसका नाम कहते हैं। It must be a positive number. And जो digits होंगे उसमें वो कहाँ से जाएंगे? 0 से R -1। यानी जैसे अब बेस 10 में 0 से लेके 0, 1, 2, 3 up to 9, right? and you have a single digit. Remember that. You have a single digit representing a discrete quantity. अच्छा, base 2 में क्या है? How many digits we have? 0 and 1. Base 8 में क्या होगा? 0, 1, 2, 3, 4, 5, 6, 7. We have digits, so we can represent discrete quantities, 8 different discrete quantities with digits. अच्छा, और base 16 में क्या हो जाएगा? Base 16 में क्या हो जाएगा? जी?
0 to 3.
So देखिए, एक single digit से हमने represent किया. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can't write 10, 1, 0. There are 2 digits. So instead of writing 10, what we write? 8. A is equivalent to a 10. Right? Then B is 11, 12, 13, 14, 15. So 0 to 15, again, right, we are representing a hexadecimal system with base 16. And later on we'll see this base 8, base 16, and base 2 has a very close relationship. Right? It has very close relationship, and we can always convert any binary number system into octal or hexadecimal, or vice versa. We will see it today. ठीक है जी? Clear हो गया? Okay. So we can say, so we have these numbers and we have some base, right? That's generalized form, right? We have some digits, right? So, and it has a base, right? And we can always expand, right, in the power series. So if we have this, and we know, if we know the radix or base, we can always expand. We know the decimal position, that is A0 into R0, right, and so on. And we know this, what is R0? R0 is basically R is partial, right? R1 and so on, usually like this. So I can represent any number system in this general form, very general. तो ये कुछ आपके सामने एग्जांपल्स आ गई. ठीक है, अगर बेस ये डेसिमल होगी तो नेचुरली पावर्स ऑफ 10 से वो वेटेजेस कर देंगे, और अगर बाइनरी होगी तो फिर क्या होगा, उसकी पावर से नहीं. अगर ऑक्टल होगा तो बेस 8 की पावर से नहीं, राइट. तो आप देखिए 8 बेस की पावर 0, 1, 8 बेस की पावर 1, 1, और ये 8 का मल्टीपल होता है. 8 से मल्टीप्लाई करते जाएं तो आपको नेक्स्ट डिजिट मिलता है. अच्छा, एक और इम्पॉर्टेंट चीज, वेरी इम्पॉर्टेंट. If I, let's say, represent a number, let's say if I represent two digits, when I represent here binary, I'm talking about binary, right? So let's say I represented 1, 0, right? So what is this number? 2, right? And maximum number I can represent is what? 1, 1. Maximum number is 1, 1, which is 3. And how I calculate? Just write down the weightages, right? And just add wherever is 1. For example, if I write 1, 0, 1, 0, I can quickly find out what is the number. How I find? Just I write the weightages 1, 2, 4, and 8, right? And wherever is 1, I mark them and just add them. 8 and 2, 10. आपको expansion की भी जरूरत नहीं है. Just because in binary it's very simple. Either it's 1 multiplied by 1 or multiplied with 0. Anything is multiplied with 0 is 1, right? So wherever the weightages are there, I'm just multiplying with 1. So I'm just adding the weightages, right? So if I write any number, I can quickly, looking at that number and writing the weightages above, I can know what is this number. Okay. So, and we said the 2 bits can represent how many quantities? 4 quantities, 0 to 3, right? And 3 bits can represent how many quantities? 8. So what if I'm adding a single bit? How many quantities I am doing? Multiplying by 2. If earlier 2 bits were representing 4 quantities, 3rd bit will represent 8 quantities, and 4th bit will represent 16 quantities. So every single bit is doubling your quantities. ठीक है, ये चीज भी क्लियर होगी. तो ये भी इम्पोर्टेंट है, लेकर ऑन हमने डिसाइड करना होगा कि कितने बिट्स यूज करने हैं। इसमें हमें पता होगा कि एक एडिशनल बिट अगर और लगाता हूँ मैं यहाँ पे, जैसे 1 2 3 4, तो आई कैन रिप्रेजेंट 16 क्वांटिटीज, और अगर 5 बिट्स यूज करूंगा फिर कितनी 30। तो इट्स वेरी सिंपल, या अगर नहीं पता तो 2 रेज़्ड पावर 5 कर दिया, तो ये टेबल आपके जस्ट रेफरेंस के लिए है, ठीक है। Okay, let's now see how we convert the numbers from one number system to another number system. और ये चीजें नई नहीं आपके लिए, ही आपने मैट्रिक में भी शायद की हो, एफएससी में भी की हो, ठीक है। So, but we are revising from the beginning. So base R to decimal. So we are generalizing any base to decimal. Base 5 to decimal, base 6 to decimal, base 16 to decimal, any base to decimal. Right? So the principle is very simple. The conversion of the number in base R to decimal is done by expanding the number in the power series and adding all the terms. What we have seen earlier, we have been doing basically number system to decimal. Right? And basically, so can you tell me what is this number? So let's try that. Let's see what is this number in decimal. ये क्लास में प्रैक्टिस भी कराता हूँ ताकि थोड़ा लाइव रहें आप लोग। तो अगर नहीं समझ आ रही बेटे, आपने पेंसिल और कागज लेके आना है, फॉलो कर लें किसी से और राइट करेंगे। जी कितना आया जी? कैलकुलेटर्स लेके आया करें। क्या जवाब आया जी? लेट्स सी एंड वेरीफाई। 515 511.2 तो नहीं हो सकता, 0.2 होगा। 0.4, somebody is saying 0.4. जी, anybody else see? ठीक है, everybody understand how to do this?
Yes.
Okay, let's see. So 511.4 is the right answer, right? So we expand the digits starting from decimal. What is the weightage of this one? 5 raised to power 0, 5 raised to power 1, 5 raised to power 2, 5 raised to power 3. So multiply these digits with the weightage and just sum them up, you get the number in decimal. You get any problems? So we can always convert any number system into decimal. Okay. Okay, decimal to base R. Now the vice versa. Okay. We are given a number and we are asked to convert it to binary, or we are asked to convert it to base 5, right? Vice versa. So what should we do? Remember? क्या करें हम? Divide कर दें. So we divide the integer part only and see the remainders. If the remainders, then we write a remainder in a particular sequence. So let's see that. Okay, let's say I want to convert this decimal number 57.625 to binary. ठीक है? मैं क्या करना चाह रहा हूँ कि इसको 57, ये base 10 है basically. It's a base 10. ठीक है? It's a decimal number system. अगर मैं डेसिमल कहता हूं तो बेस 10 लिखने की जरूरत नहीं है, बस अंडरस्टूड कि इसकी बेस क्या है 10 है, राइट? एंड आई वांट टू कन्वर्ट दिस नंबर इनटू बाइनरी, सो आई वांट टू राइट सम नंबर इन वंस एंड zeros and that base is 2. So what should I do? I simply take the integer part, I take the integer part 57 and then try to convert this into required base. I divide it by required base. So my required base is base 2, right? So I divide this number with 2, right? And write down the remainder. So 2 2s are 4, right? And this is 17, 2 8s are 16, and what is the remainder? 1, right? And then I again divide. So I keep dividing by 2 and write the remainders here. So I'm writing the remainders, right, on this side. So 2 1s are 2, 4, 0, right? And then 2 7s are 14, 0, right? 2 3s are 6. I have 1 here, and then I divide it by 2. 2 ones are 2, right, and 1 here. So when I stop, when my number is less than the base, right, then I stop, right? And what is the number then? So remember, the sequence will be like this. The sequence will be like this. So what is the number then? 1 1 1 0 0 1 is equivalent to what? 57. Okay? So I write the sequence. So this is my least significant bit, and this one is most significant bit. यानी ये मेरा जो है ये least significant bit है और ये मेरा क्या है most significant bit. ठीक है? So I take the number, whatever is the number in that decimal, right? I divide by the required base. If I was converting into base 5, so I keep dividing by 5. If I was converting into base 2, then I keep dividing by 2. Right? And then I write the remainders, then you can cross check. Can you cross check is it equal to 57? Just write on the vertices on the top and add where the 1 is there. Right? So I have 1, 2, 4, 8, 16 and 32. So what is that? 16 plus 57. So you can. तो इसमें मजे की बात यह है कि आंसर भी पता है, आप उसको वेरीफाई भी कर सकते हैं. You have converted into number, and then you expand it, you will find the decimal equal. ठीक है जी, बात समझ में आ गई? अगर कहीं मैं तेज जा रहा हूं आपको समझ ना आए, so repeated division करनी है like this. So we do the repeated divisions, just write down the remainder, and that will be your required binary number. ठीक है जी, ये तो हो गया इंटीजर पार्ट. अब डेसिमल पार्ट जो 0.625 था उसका क्या करें? Yes, so we have to treat both the numbers separate, integer part and the decimal part. So उसका क्या करना है? Repeated multiplication. इसमें क्या होगा? Repeated multiplication. Okay, let's see that. Repeated multiplication for decimal part, right? तो कुछ ये इस तरह का हो जाएगा. चलें, let me do it. ठीक है जी, तो मैं क्या करूंगा? 0.625 लूंगा, 0.625, and then I multiply with the required base. And what was the required base? The binary, right? Base 2. So I multiply, so 10 here, 4 and 1, 5, 6 2s are 12. And I write the decimal part here. Okay? And then I ignore this and only multiply the decimal part. I ignore this and multiply on the decimal part. फिर इसको मैं 2 से multiply कर दूंगा. ठीक है? तो ये क्या आ जाएगा? ठीक है? 0 आ गया? 2 5 are 10, 5 0 आ गया. ठीक है? Then I forget it. Only I take the decimal part. Again multiply with 2. Right? So what you get? 1. तो आगे अब मैं नहीं चल सकता क्योंकि ऑल जीरोज हैं. ठीक है? तो इसको मैं ज़ाहिर है 0 को 2 से मल्टीप्लाई करूंगा तो 0 ही रहेगा. सो अब मेरे पास रिक्वायर्ड नंबर क्या हो गया? ये. सो नाउ लुक एट द सीक्वेंस. I go like this, right? This is my, so 0.625 is 101, sorry, 0.101, right? Or 0.101 in base 2. ठीक है? So I write the sequence. I write, earlier मैंने कैसे किया था? और जो मैंने डिवीजन की थी वो नीचे से ऊपर किया था. अब यहाँ से ये जो मेरे पास डेसिमल नंबर्स आए थे इसको मैंने ऊपर से लिखा. Just write down the number. किसी नंबर से. Not only binary, you can want to convert any decimal number. लेकिन आप कह रहे हैं decimal to base R. R उसमें क्या हो जाएगा कि R2 थी, इसमें आज क्या हो जाएगा, अगर बेस 6 से करें तो 6 से मल्टीप्लाई करें,
अगर बेस 5 to बेस 2
जी वो भी हम देखेंगे, एक बेस से दूसरे बेस में कैसे, वो भी हम आपसे पूछेंगे कैसे करना है। ठीक है जी, अंडरस्टूड? सो द होल नंबर आई कैन राइट, आई कैन एक्सप्रेस द full number 57 which I had calculated earlier like this, 0.65 I had calculated at 0.101, and I can combine and I can express in that base. Sure. So now you can convert any number to decimal and then decimal to any base, right? Okay. इन्होंने क्वेश्चन किया कि लेट्स से मैंने एक बेस से दूसरे बेस में जाना, so that's the next step, right? और वो हम देख लेते हैं, कन्वर्जन बिटवीन टू बेसिस, राइट? तो क्या करना चाहिए आपके ख्याल में? अगर लेट्स से एक नंबर मेरे पास है बेस 5 का, राइट? आई हैव 304 बेस 5 और इसको मैं कन्वर्ट करना चाह रहा हूँ बेस 7 में, क्या करूँ? क्योंकि हमने यही सीखा ना, बेस किसी आर बेस को डेसिमल में कैसे ले जाते हैं और डेसिमल से दूसरी बेस, तो हम एक इंटरमीडिएट स्टेप करते हैं, फर्स्ट कन्वर्ट दिस इनटू डेसिमल एंड देन कन्वर्ट दैट डेसिमल इनटू डायरेक्ट मेथड भी है। अगर इफ यू नो द अरिथमेटिक इन दैट नंबर बेस नंबर से आप डिवीजन उसी तरह रिपीटेड मल्टीप्लिकेशन और डिवीजन करेंगे, लेकिन आपने उसी basically number system में ही रहना, वो बड़ा डिफिकल्ट होगा। You can do that, but you have to, क्योंकि आप उस नंबर सिस्टम से फेमिलियर नहीं है, बेस 6 और बेस 7 से आप नहीं है, या बेस 5 और पुराने जमाने के लोग नहीं है, so you are not familiar, so हमें कन्वर्जन वाला तरीका ज़्यादा ही है। जी? लॉग से? लॉग बेसिकली लॉग क्या है? बेसिकली वो एक्सपोनेंशियल है ना? हाँ, basis change हो रही है। You can find a new method maybe. Okay? But let's go a very easy way. Convert it into decimal and then convert it back into the system. ठीक है जी? So ये हमने adopt किया, ठीक है? और decimal से base A से decimal में कैसे जा रहे हैं? हमेशा decimal में जाएंगे तो power से, और decimal से किसी और में जाना है तो डिवीजन है, रिपीटेड मल्टीप्लिकेशन। ठीक हो गया जी? एनिमेशंस कैसी हैं जी? ठीक है, लाइक दी एनिमेशंस? अच्छा, अब थोड़ा सा देख लेते हैं ये जो कंप्यूटर मैनिपुलेट्स माइंड, वी मस्ट बी मोर फेमिलियर विद द कंप्यूटर, और हमें पता है कि ये बाइनरी, ऑक्टल और हेक्साडेसिमल में बड़ा अच्छा एक रिलेशन है। तो अगर ऑक्टल को हम देखें तो ऑक्टल बेसिकली क्या है? ऑक्टल इज बेस 8, राइट? और ईच डिजिट कैन रिप्रेजेंट हाउ मेनी क्वांटिटीज? ईच डिजिट
7
सिंगल डिजिट कैन रिप्रेजेंट हाउ मेनी क्वांटिटीज? 8 क्वांटिटीज। हमें पता है कि वो डिजिट की वैल्यू जो होगी 0 से लेके 7 तक होगी, और it can represent 8 quantities, and 2 bits can represent how many quantities? 64 multiplied, right? So 0 to 63 and so on, right? और इसी को देखते हुए हम देखेंगे। और अगर ऑक्टल को देखें तो हमने कहा कि ऑक्टल क्या है? ऑक्टल इज बेस 8 and my digits, look at the digits, 0, 1, 2, 3, 4, 5, 6 and 7. अच्छा, अब ये जो digits हैं 0 to 7, this is a single digit है base 8 octal, right? Can I correlate this with binary? Can you correlate each digit with binary? उसका relationship निकाल सकते हैं? तो 0 को कैसे रिप्रेजेंट करूंगा? और आई वांट टू मैक्सिमम मैं 7 तक जाना चाह रहा हूं, कितने बिट्स यूज करूं? सो आई नीड 3 बिट्स, अगेन द सेम प्रिंसिपल, राइट? सो इसको 0 को मैं कैसे रिप्रेजेंट कर सकता हूं बाइनरी में? ये ऑक्टल था मेरा, दिस वाज ऑक्टल, राइट? और बाइनरी में कैसे लिख सकता हूं इसको मैं? 0 0 0, ये 1, ये
Zero one zero one zero.
good, ये 0 1 1, 4,
1 0 0.
then
1 0 1.
1
1 0. 1.
so now you know the binary equivalent. तो अगर कहीं ऑक्टल लिखा हो उसको बाइनरी में करना हो तो क्या करेंगे, उसको रिप्लेस कर देंगे इस इक्विवेलेंट बाइनरी, सिंपल। और अगर कहीं बाइनरी से ऑक्टल में जाना है फिर क्या करेंगे, थ्री डिजिट्स को कंबाइन करके एक डिजिट बनाना। तो लेट्स प्रैक्टिस दैट। ठीक है, कॉन्सेप्ट समझ आ गया जी? अच्छा, ये बाइनरी है, इसका मैं ऑक्टल बनाना चाहता हूँ, क्या करूँ? एक तरीका तो ये है कि आपका तरीका है कि इसको डेसिमल में लेके जाऊँ, फिर डेसिमल से दोबारा बेस 8 में लेके। लेकिन हमें पता है कि ये ऑक्टल, बाइनरी और हेक्साडेसिमल में बड़ा स्ट्रॉन्ग रिलेशनशिप है, तो वी कैन डायरेक्टली डू दैट। क्या करूँ? ये मेरा नंबर 1 और 0 लिखे हुए बाइनरी में है, तो मुझे पता है कि यहाँ से मैं स्टार्ट करूँगा और मैं क्या करूँगा, 3 के पेयर्स बनाते जाऊँगा। मुझे पता है कि हर 3 डिजिट का जो पेयर होता है वो 1 ऑक्टल के बराबर होता है। ऐसे हर 3 डिजिट जो होते हैं वो एक ऑक्टल डिजिट के बराबर होते हैं। तो आई स्टार्ट पेयरिंग, ठीक है। सो आई स्टार्ट पेयरिंग है, रेड कलर यूज कर लेते हैं। सो आई यूज द पेयर लाइक दिस, ठीक है। ये वैसे ही गैप बना हुआ है, लेकिन अगर ये कंटिन्यूस लिखे हुए हैं तो मैं पेयर्स लिखूंगा और डेसिमल के बाद भी 3 के पेयर ले लूंगा, ठीक है। अगर इधर 0 नहीं है, अगर लेट्स 2 डिजिट हैं तो एक 0 और लगा दूंगा। आई कैन अपेंड जीरोस ऑन द लेफ्ट साइड ऑल्सो, ऑन द राइट साइड ऑल्सो, उससे कोई नंबर में फर्क नहीं पड़ता, लेकिन 3 के पेयर बनाने जरूरी है। अच्छा, तो पहला नंबर क्या हो गया जी? 101 इज व्हाट? अच्छा बेटे याद रखें, देखें 1 2 4, 4 and 1 is 5, इमीडिएटली आपको पता चल जाता है ये नंबर क्या है। तो दिस इज बेसिकली 5, और ये क्या है 6, ये क्या है 2, ये क्या है जी पॉइंट तो लगेगा 3, और ये क्या है 1, तो ये क्या बन गया? बाइनरी से ऑक्टल तो डायरेक्ट आपके पास रिलेशनशिप है, तो आप इसको पेयर बना के उसकी इक्विवेलेंट जी अब इसको एक्सपेंड करके देख लें बेटा, इसका बाइनरी बना लें। इसका बाइनरी क्या बनेगा? वही चीज है, मतलब जी 2 की जो पावर में होगा उसको हम ये तरीका लगा सकते हैं। वेरी गुड, माशाल्लाह, वेरी इंटेलिजेंट पीपल है। अच्छा जी, ठीक है जी, ये आ गया। ये बता सकते हैं आप क्विकली? ठीक है जी, ये अब उल्टा बाइनरी में जाना है। ठीक है जी, अंडरस्टूड। ये 0 का 3 0 लिखेंगे, रिमेंबर 0 के 3 0 लिखने आप, एंड सो ऑन। वैलिड है ऑक्टल? क्यों 9 आ गया? क्योंकि हमें पता है कि डिजिट्स दे कैन गो फ्रॉम 0 to 7। अच्छा, हेक्साडेसिमल का भी यही कहानी है, उधर क्या होगा? बस 4 डिजिट्स आ जाएंगे और कुछ। द सेम रिलेशनशिप गोज देयर। नाउ वी नो। अच्छा, वो जो डिजिट्स हैं 9 के बाद, वो A B C D, उसका ख्याल रखना है। तो इसको क्विकली कर सकते हैं, ठीक है जी। ये 9 है, ये 10 है, 10 को A लिखेंगे, तो वो डिजिट्स इक्विवेलेंट डिजिट्स आते हैं, ठीक है। तो ये यू कैन प्रैक्टिस, ये मैं आपको स्लाइडें में ये सब कुछ छोड़ दूंगा। यू कैन ऑलवेज कन्वर्ट वन नंबर सिस्टम इनटू अनदर सिस्टम, ठीक है। तो आपको चले ये होमवर्क कर लेते हैं। 0 से लेकर 20 तक आपने लिखना है, ठीक है। और आपने एक पहले कॉलम में डेसिमल लिखना है, फिर आपको बाइनरी लिखना है, फिर ऑक्टल लिखना है, फिर हेक्साडेसिमल, और इसका पर्पस 0 से 20 का 100 तक भी दे सकता था होमवर्क, लेकिन पहले 20 तक क्योंकि वी आर नाउ गेटिंग टू न्यू नंबर सिस्टम व्हिच इज बाइनरी। कंप्यूटर की जुबान में हमने बात करनी है, तो उसकी जुबान सीखनी पड़ेगी। 1 2 0 और ऑक्टल हेक्साडेसिमल क्यों हम रिप्रेजेंटेशन देखते हैं? Can somebody tell me why we are representing in octal and hexadecimal? विजिबिलिटी के लिए, ह्यूमन इंटरेक्शन के लिए, क्योंकि 1 तो 0 इतने ज्यादा हों उनको पढ़ना मुश्किल है, हेक्स में उसको पढ़ना आसान। ठीक है जी, होमवर्क कर लेंगे आप। चलें, द लास्ट स्लाइड, आई थिंक यू विल एंजॉय दैट स्लाइड। ये समरी है, समरी यू ऑलरेडी डन। ठीक है जी, सो दैट्स द एंड ऑफ द लेक्चर। ठीक है, चलें, गुड, ओके, थैंक यू।